Welcome to Reality Creative Video. I'm Hermes, and today I want to talk about my video laser containment system that I use with the Andon Star microscope. And my knowledge of colloidals would not be where it is today if it wasn't for my ability to look at the colloidals in the microscope. I don't have an electron microscope. Can't afford one. So I had to improvise with how to look at colloidals. In the beginning of doing colloidals, like everybody else, you're looking for ways to figure out how to make the colloidals and, how do you tell if you have the colloidals? And one of the basic things that somebody figured out a long time ago was that if you take a laser and you put it through a colloidal, the metal particles will illuminate. Even though it takes a electron microscope to see the particles, you can, with the laser beam, you can illuminate the particles, get the reflection off of those particles. It's not the same thing as actually seeing the nanoparticles on a nanoparticle scale, but I figured if there was a way to amplify that picture, that signal going through the beaker, then I would be able to maybe tell something about the colloidals I couldn't normally tell. And boy, it has opened up my ability to tell the quality of a colloidal, the parts per million of a colloidal, because, material used does not always equal parts per million that you get out. Depending on how you cook stuff, you could cook 2 milligrams of material and get 10 parts per million in a solution. You can cook use 8 milligrams of material and get, 1 parts per million in a solution. It depends on the colloidal, it depends how you're cooking it, and you can't tell any of this from the standard laser beam test. Now, the standard laser beam test, here I have distilled water. This is a colloidal mixture in here, okay, but here's distilled water. I'm going to put distilled water in here just to show you the laser beam. And I'm going to wear dark sunglasses because I'm going to use the green laser. It's very powerful and it has a tendency of bouncing off the walls, which is one of the reasons I've designed the laser containment system, because this can be dangerous. All right, so if I take my laser and I put it through the distilled water, you will see nothing. The light goes here, exit there, nothing in the middle. Now this is a colloidal substance in here. It's what I call my forever mix. It's a combination of all different colloidals, but I just bringing this out because it is a spectacular beam. Now do this, and then look at the difference. Beam goes in, you can see the line through it as it's illuminating the colloidals, and the beam comes out. That's the premise. Now, if none of you have a microscope or a laser scope like I have here, because I designed that system, you wouldn't have it naturally unless you downloaded the blueprint for it and made it yourself, or made your own something similar. The laser beam is the only way you can get a general idea of the strength of your colloidal as you're making it. This beaker here is made up of about 30 parts per million. Various colloidals, copper, platinum, gold, silver, all mixed together in what I call my forever mix. And it makes a nice strong beam, which is why I'm using it for the demonstration purposes. Now, but that only tells me the intensity. That doesn't tell me the shape of what the colloidals look like, if they're healthy or not. And these are things I didn't know until I created the laser containment system. Now let me just show you how that works. I have a little beaker here, and I will fill that with appropriate amount of fluid. Then, all right, I'm going to come over here. This is my laser containment system. I will show you that up close in a minute. Put it in here. This cover prevents the laser light from shooting into your eyes. This whole thing prevents the laser light from shooting into your eyes. Turn this on. Laser is on, and then this is a 4x lens I'm using, which is usually good enough for everything, unless I want a real close-up picture. And I will, as you can see, I will, of course, put the video of this up there for you. You can see the colloidals floating in the solution. So through many trials and viewings of different colloidals in there, I have a pretty good idea of what a good colloidal is and what a poor colloidal is. And this system here is printed. Let's get this down. Take this out. This is all printed on a 3D printer. This is a laser, a green laser, because the green laser is brighter. It unscrews. I've used this kind of laser. It's just a regular laser pointer. All right. I've got the end of the laser pointer hot glued to the device that contains the thing. It's got a hole in here for the thing, for the so the laser light can go through. And I got it, very importantly, I got a piece of cloth at the other end, because believe it or not, this laser will burn a hole through this plastic. So the cloth dissipates the heat so it doesn't burn a hole through the device here. This little thing here is just a spacer for the crystalline dish to bring it up to the proper height so the laser can go through. If you took this crystalline dish out, you could put one of these things in here instead, deeper dish, but the Anden star microscope cannot drill down far enough for this. If you had a different kind of video microscope, this might work, but it doesn't, so I had to modify it. But still, the capability is there. These lasers are available on Amazon. It's the green laser, and this particular rig is made for the Anden star. It slides on here like this. It's the top. So, I mean, if you want maximum compatibility with what I've made here, you'd have to get an Anden star microscope. But if you're planning on looking on colloidals, this thing works pretty well. I've changed the lenses in it, put a little better lenses in it, but you don't have to. The lenses that come with it do work fine. I just naturally, my lab work is so critical, I wanted better quality lenses, so I replaced the lenses on there. So that's basically it. That's how the laser containment system works. That's how it came about. And please, when working with lasers, dark sunglasses. Doesn't take much to ruin your eyes. Be very, very careful. Safety is absolutely important, especially working with a green laser. You can get a red laser, but it does not. The images are not as good using the red laser. The blue laser, the images are totally useless. So that's it. I will have more on the inner workings of the laboratory here down the road. I'm Hermes. This is Reality Creative Video, Alchemy, and I will talk to you again soon.